I'd like to talk about the greenhouse effect today. You've probably heard a lot about it. The greenhouse effect is a natural occurring effect that keeps our planet much warmer than it normally would be. And the reason is because we have an atmosphere. We have quite a thick atmosphere. And so when solar radiation comes into the Earth, and it brings all sorts of energy in many different forms, we get energy in the form of visible light and heat and ultraviolet radiation and X-rays and radio waves and so forth. It hits our planet, and for most planets they'd lose an enormous amount of energy, but for us, because we have a very, very thick atmosphere, a lot of that energy is actually trapped inside there. It's like putting a blanket on top of yourselves, and so our planet retains a lot more energy than it should. It stays a lot warmer than it should. Okay, so how does this actually happen? Solar radiation. So the sun is providing all the energy to the Earth in the form of electromagnetic radiation. And as I said before, that can be all sorts of different types of rays coming in there. And they come in at different wavelengths and at different energy levels. We won't get into the physics of it too much. Now, most of that energy is absorbed by the Earth. That's a good thing. But a lot of that energy could still be radiated. It bounces off of the Earth. And it should be lost back to the atmosphere. However, what happens, though, is that when light is received by the Earth, and it bounces back, it loses energy. And so when it bounces back, it actually has a different wavelength than it did when it came in. So let's just draw this so you understand what I'm talking about. So let's suppose that energy comes into the Earth like so, right? And it comes in at some certain wavelength with some certain energy level. So it's got a lot of energy, shall we say, right? Now the Earth is going to absorb a lot of that energy, right? And so when it bounces back, it's at a smaller energy level than it was when it came in. And that smaller energy level, since it now has a different wavelength, has trouble getting out of our atmosphere because there are gases. So let's go ahead and draw that. There are gases then that keep that guy in there. So it remains in here and it bounces back and forth, and we keep absorbing more and more energy from it. Let me say it again. When light comes in, when radiation comes in, it's high energy, right, and short wavelengths. Energy gets absorbed by the planet. It then bounces back out at a smaller energy, but a longer wavelength. And that longer wavelength cannot get through the atmosphere, and so it stays inside. So the gases in our atmosphere help us to retain more of that energy coming in, and this causes an increase in the temperature of the planet. And we call it the greenhouse effect. Who are these gases then? So these gases are very, very special. They let solar radiation come in, but they don't let reflected radiation leave the Earth. Who are these guys? Well, there's lots of gases in there, but I'd like you to know the major ones. Carbon dioxide. And that's why we spent some time talking about carbon dioxide the last couple of days. Now, what's important about carbon dioxide? Carbon dioxide is naturally produced. I mean, it comes from volcanoes and decaying matter. We saw that in our carbon cycle. But the important thing is that carbon dioxide is the gas which is increasing the most in the atmosphere, and it's because of man-made industrial contamination and pollution. Then we have water vapor. That's a naturally occurring gas. Then we have methane. Now, methane also is a naturally occurring one. It does come from industrial sources too, but surprisingly, you can get a ton of methane gas. I know this sounds silly, but just from herds of cows or decaying dung and so forth. Then there's ozone. Now, ozone is not to be confused with oxygen. It actually is a molecule that's not O2 but O3. And ozone is found quite high up in the atmosphere. So we have different layers of the atmosphere. And the purpose of ozone, which is way, way up here in the stratosphere, ozone will take UV radiation and it will absorb it and it bounces back so it doesn't get in to us down here in the planet, right? So ozone takes out UV radiation. And we'll talk about this next time about how there are holes forming in the ozone layer, and that's a bad thing. Finally, there's nitrous oxide, which is NO. Now, nitrous oxide is really interesting because the only place it can come from is man-made sources. And one of the major places, of course, nitrous oxide is coming from is from the tailpipe on your car. Okay, global warming. So, we have a buildup of these greenhouse gases from the burning of fossil fuels, which has dramatically increased the overall temperature of the Earth. Now, a lot of people will say, oh, that's silly. I mean, there's places where it's just snowing, it's freezing. What are you talking about, global warming? Well, the reason why we did that activity on carbon dioxide, looking at the cyclical nature of it and then the average temperatures, is to understand that even though you will have variation at any given place on the planet, the overall average temperature has been increasing quite a bit. Now, a lot of people say, oh, that's also silly. What are you talking about increasing quite a bit? It's only gone up in the last 100 years like 1 degree or I think 1.5 degree, big deal. On any given day, the temperature fluctuates, 20, 30 degrees, so what are you talking about? Yeah, that's true, but again, we're talking about the average increase. So when you talk about the average increase of only 1 degree over the entire planet, that's a big deal in the amount of energy that it represents. And this has caused unequal temperature and climate conditions around the world. And that's really interesting too. A lot of people think global warming is all about just warming. It's called global warming because it's about the average increase of temperature, but the effects, the symptoms of it are often not temperature. So we see a lot of hurricanes, a lot of tornadoes, a lot of violent rainstorms, blizzards, radical weather patterns because the temperatures have changed on the planet. And we've seen it most dramatically in the melting of ice caps, particularly in Greenland and Antarctica. Recently there was like a huge 75-mile piece of ice that just knocked off in Antarctica. Okay, so what are the effects of global warming? We always like to have a list of examples we can put down here. You don't need to write them all down here. Let's just write a couple of them. The one I just mentioned, of course, is obviously important. Glaciers melt. Very, very good. Let's talk about this one. There are species that are going extinct because of the change in temperature. Now, being sophisticated animals, being warm-blooded, being mammals and so forth, we can kind of roll with temperatures. But a lot of more primitive animals, they can't, particularly if you're cold-blooded. So we saw like the El Nino effect in the oceans when you have a small temperature change. The fish have to go ahead and migrate or else they go extinct. And so that leads us into species migration. Animals have to get back to where they feel comfortable in their temperature. We have a huge loss of habitat. That's why they're migrating. And because the glaciers are melting, we have sea levels rising, which is going to be a big problem for a lot of countries that are lowland. And again, we saw extreme weather conditions. Okay, finally I'd like to talk about a biological idea. This is called the Precautionary Principle, which kind of means to look before you leap. And it's very, very different from the way a lot of other things work. So, for example, the way typically things work is that you do something really bad. Somebody says, gee whiz, I think you should do something about it. You say, well, let me go ahead and investigate the problem. And if it comes out to be bad, I'll go ahead and fix it. The precautionary principle is exactly opposite. You fix something before you go ahead and do it. So, those responsible for change must first prove that it will do no harm before they proceed. Therefore, let's talk about global warming and greenhouse gases. Suppose you are producing greenhouse gases, you must first prove they will not have a damaging effect. And this is very opposite of the way we normally think. Now, a number of years ago, there was a big agreement signed by, I can't remember, like 100 countries or something, called the Kyoto Protocols, and it was an agreement to limit the amount of greenhouse gases, right? That was based on a precautionary principle. And the United States refused to sign it First of all, because we are the major producer of greenhouse gases, and we said, no, 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 no. You go ahead, first of all, and show us that what we're doing is bad, and then we'll go ahead and ratchet back. But we won't stop beforehand until you think about it. So we kind of took the opposite principle, and as a result, we never signed that agreement. Okay, let's go ahead and evaluate the precautionary principle in terms of global warming. Should we leave the problem for future generations? Maybe. A lot of people will say, hey, this is a long-term problem. The temperature of the world has only increased, what did I say, 1 degree or 1.5 degree over the last 100 years. You know, another 100 years, so what? So another degree, maybe not a big deal. Maybe in 100 years, we'll figure out some way to deal with the problem. So it's not going to happen tomorrow. Number two, what are the economic considerations? Well, a lot of people will say, you know, wow, this is really going to have an effect on crops and livestock because weather conditions are changing. But the other side of the coin is, hey, the human race is very adaptable. You know, we went through the Ice Age. Don't worry about it. We'll come up with technological solutions to these problems. Number three, what is the international involvement? So the reason we didn't sign the Kyoto protocols was that we are the ones who would suffer the most from limiting industrial output. Other countries wouldn't. Or a lot of people in the United States have said, hey, you know, why should we go ahead and sign this agreement if other big countries like China, for example, are refusing to sign this agreement? We shouldn't be holding the bag by ourselves. And finally, what is the effect on rich versus poor nations, right? So if you're a poor nation, going ahead and doing this won't have a big effect on you because you didn't have much to begin with. But for us, if we go ahead as they wanted to and limit our output by 10% of greenhouse gases, this would have a huge economic result for our country.